Yeah, so I'll try not to go too deep on anything here, but it's worth just giving a bit of background on the loader again. It's probably going to be repeating a few things, but I hope it helps to clarify, at least to have a standard background, and then I'll go through some of the use cases of the loader hooks, what loader hooks we have currently, and what future hooks we might sort of consider. So as you know, the core of the loader is this URL-based registry, and these are the string keys that uniquely identify each module. In Node, they're file URLs, and the reason for this is to ensure that the resolution is the same in the browser as it is in Node. So things like path normalization rules are all given to us, the character encoding handling. It's worth noting that we do use percent encoding in the unique string keys. When that hits the file system, the string encoding, the percent encoding gets undone. And so you can still load files with odd Unicode characters and stuff. So the other thing about the loader is so it forms the central module registry where we go from a unique string key to the module object that then associates with the individual loads and ultimately the namespace record, which contains the named exports of the module. When you load the same module key twice, you will get the same module instance. There's it's kind of the pointer modules. But the same also applies to errors. So if there's an error in loading, the error is cached against that same key. It's worth noting that there isn't currently a way to reload a module or flush errors. I guess it's kind of the same in the CommonJS require. I'm not sure offhand, does the CommonJS require retry on an error, or does it cache an error? I shouldn't really know this. Maybe someone knows, Bradley?
So it retries. There are ways to force it because we expose the require.cache to throw errors if you import, but by default,
so that is the difference.
Fails. It just repopulates.
Okay. So yeah, there isn't currently anything to do this. There could be some kind of registry APIs like the loader drafts have for clearing out errors, and so that's another topic that could be worth considering. In terms of how the loader is implemented, we've got this main class and then a main instance of this class that kind of does all your loading in Node. And it's got this module map, which stores that core registry. I can't see the chat, but please just anyone let me know if there's any clarifications that I should stop to answer.
I think we have a question from Wes.
Sure.
Since module resolution is cached, there's no way to ensure a module gets executed after the module you're currently writing. Is that true?
Sorry, could you just clarify that actually?
So in CJS, you can say require thing A, then do some polyfill work, and then require thing B.
Right.
And you can even flush the cache before you require thing B to ensure that thing B actually executes after your polyfill code executes. In ESM, there's no way to do the equivalent.
Well, you can just add another file, right? You can just have a file that first imports your polyfill and then imports the other file. But you need an additional file for that, yeah.
Yeah. But if the other file you're importing also imports your polyfill, the execution order can still be determined. Like if you have to import code that you did not write and you need to make sure that your code executes before it, you can't actually guarantee that.
Yeah, but the polyfill will always have executed before the new file that you import executes.
Your imports will always, yeah. Your imports will always execute in order, and that's one of these kind of spec things, is that no matter how they load, the execution order is the order of the imports in your file. The only case where that can be invalidated is if there's a circular reference. But if it's your code, you probably know that the other imports that you're importing won't have a circular reference back on your code. So in most cases, you can kind of rely on that. Does anyone want to clarify that further?
I just think there might be some confusion, so I'm going to rephrase it how I understand what's being talked. So when ESM executes, it has a very well-defined evaluation order for these module graphs, which are turned into trees. In particular, it does post-order depth first evaluation. So if I have import A and it loads B, and then I have import B after my import A, it will always execute B, A, B, because we only have our entry point, the A module, and the B module. So if the question is, can you force collisions and resolution to reload things? No, and that's part of the JavaScript spec, as we said. However, there are ways around this. I'm sure we'll get to them with the loader talk with hooks somehow. And there's also, since we're using URLs, you can use search parameters if you can cache bus that way, or you can use the fragment parameters if you want to cache bus that way. Yeah.
Thanks, Brett. Okay, so yeah, you instantiating this main loader, and it has the associated module map caching those URLs to their modules, and then the loader has the main method on the loader is this asynchronous import function, which takes a module specifier to import and a parent URL to resolve it relative to, and provides that top level execution process. And it'll actually initiate a top level execution, which is kind of a well-defined thing in the spec. It sort of defines an execution group, as it were. So one thing about this loader class is it's very specifically not exposed at all to users in Node. It's never touching anything that users can get hold of through any type of JavaScript. So it's very much a private API, and it's something that at some point we could consider making a public API. But for now, in general, the way we've approached the work on this stuff is that as much as possible we're locking down and being conservative and thinking carefully about what surface areas we're exposing. And then the other method we've got here is a hook, which will likely be applied before it always is applied before you do any actual imports with the loader, and that allows to hook into various parts of the pipeline. The Bootstrap is something like the following. When I'm running Node with experimental modules, and I'm loading a file called x.mjs, we're resolving that into a full file path on the file system before it gets to the loader. We're converting that into a file URL. We're instantiating the loader. We're applying any hooks to the loader, and then we're importing that full file URL. And then that's basically running to completion. If there's any errors, then the catch handler can go to Node error handlers and things like that. And that's roughly the Bootstrap. And note that when we switch to experimental modules, this applies for all module loads, including CommonJS. The reason being that it allows the ESM resolver to kind of be, at some level, a source of truth to begin with, and then it can hand off to the CommonJS loader as necessary. But I'll get into that a little bit more just now. So these are some of the responsibilities of the loader. Module resolution, how you get from a specifier into the full path to that specifier in the file URL, specifically implementing the Node.js resolution algorithm, determining how to load a module, whether it's an ES module or if it's a JSON file or an add-on or whatever, delegating to built-in module loading, and managing those jobs from initialization to completing instantiation, and then execution, ensuring circular references and spec semantics, and then finally error handling, and ideally with beautiful error messages that would be incredibly informative. At the moment, not very informative error messages, but we're getting there. And it's worth noting with this that this is entirely separate to the VM.module work. You can kind of think of it in terms of VM.module basically wrapping a lot of the V8 APIs that the loader directly builds on. So it exposes the sort of very raw, low-level ways in which the loader itself is built. For example, we could rebuild the loader itself on top of VM.module if we wanted to. It's also entirely separate from the CommonJS require system. So we're not rewriting any of CommonJS require. We're not altering anything that's happening there. When you load a CommonJS module, it's going through exactly the same code paths, and we're getting full backwards compatibility. This ES loader is just delegating through to the CommonJS system. And yeah, sorry, so that's all I really wanted to say on the loader, and now we can get to the hook stuff. The use cases of hooks, I've just put some down roughly, I hope we can get a section of the use cases document that kind of roughly refers to these, and I'm sure there will be more. But things like custom module resolution, and these are things that people already do today in Node through the semi-private APIs we have through require and module. So being able to have custom extensions, modules that maybe are instantiated in memory and don't correspond directly to what's on the file system. Code coverage instrumentation, custom source translations. Sure, let's see what the question is here. I'm just gonna leave the chat open so I can actually maintain some context. APM is, seems to be quite, as far as I can tell, quite an important use case in Node, specifically because of some of the major Node companies involved in these areas. So as far as I can tell, the use cases around this are things like being able to inspect what the exports of a module are when it's executed, and maybe add some wrappers around that. Maybe inspect the execution and be able to tell when those exported functions are called, how long they run for, and provide some reporting and analytics around the application. So we'll cover that briefly. And then the other thing is that we should be able to compose loaders. So if you've got one system that's applying some APM functionality, and you've got something else that's creating virtual modules or custom resolution, you should be able to easily compose those things together. Bradley will be talking about that briefly. He's got a PR for it, which allows basically joining together loaders, something resembling a middleware pattern, like you get in Express or something like that, where you can delegate from one loader to the next and have a sort of an order of precedence. And that seems to be quite an elegant model to handle it. But it's also an open question at the moment. The main hook is the resolve hook, and it's kind of the most important. What we have today is the ability to write a file, say loader.mjs, export this resolve function from it. That's an asynchronous function that can then filter specific module specifiers it wants to change the resolution of, and return back this object that has a URL and a format associated with it. The URL is a full file URL. It'll get renormalized as well. So if it's not a valid URL, you get an error on that. And then the format associated with it is one of the specific module formats. Now, we didn't have to return the format here. We could have had another hook that sort of asked how to load a module. But this kind of allows the resolve hook to be self-contained. And especially when we're coming from an aspect of starting with the minimum viable hooks, as it were. The kind of thinking here is, if you think in the browser, the module format that you're getting is determined by the MIME type of the module. So if it's the content type, it has to be application JavaScript when loading a module. For WebAssembly, it's looking like it has to be, or as of the latest Chrome, it's locked down now. So it has to be the WebAssembly MIME type to load WebAssembly. And I guess it's looking like the binary AST format will go the same way. So kind of thinking of this resolve function is kind of similar, that you're resolving to a URL and some headers associated with it, including the format. The other thinking here was that this effectively takes over from the metadata that we used to pass in the spec, where there might be other things we could add to this object, like, for example, integrity metadata, if you wanted to give the integrity of a module. it could possibly be added as a field in this resolver. And that might be one way to do this sort of out of band management. And please do stop me if there's any questions. Hopefully, there's just a little bit more to go, so I will stop talking soon, don't worry. The specifier is when you write import and you type the string that you're importing from. It's the module name string. It's called a specifier. Sorry, I'm using terms from ES3. Yeah. Were there any other questions? Sorry, I can't see the hands up either.
So this can be theoretically a way to say all JS files are ESM.
Yes.
Thanks.
And then in this example resolver, we're falling back if it's not matching our custom. So this is specifically import foo from custom that we're going to our custom path. If it's not custom, we're falling back to the default resolver. At the moment, that default resolve is passed through as the third argument of the resolve hook. Now, there are a number of ways this could be done. It could be a this.resolve. At the moment, this is not defined at all. We're not exposing anything. There could be something like that. Also, in Bradley's PR for multiple loaders, all of these hooks become a closure, where the function of the closure becomes your middleware function to give you the previous resolve. So the default resolve would come through a function closure. And so that might change depending on how exactly we want to handle that. Yeah, and that's it. So then you're delegating back to the default resolver, which implements the node modules resolution, and that way all other modules will load the same way. We can then apply that loader by using the loader flag when running load, or more easily through node options. And then we pass the path to the loader. The loader actually gets loaded in a special isolated loader so that the loader still applies for everything loaded. And then we go ahead and load that file, run the resolver, and if x.mjs imports custom, it'll now get it from the path we set as an ES module, for example. Yeah, so that's kind of what we have. And the next we have is the dynamic instantiate. And it's the same kind of idea. You write a resolver, and then instead of returning format ESM, you return format dynamic. And when you return format dynamic, it'll then run this separate dynamic instantiate hook that you can write, which passes the URL. It's an asynchronous function as well. So you could do things like fetch the source from a custom location. And then as in the spec, we have to know the exports ahead of time at instantiation time. And then the execute function itself is synchronous, which takes the exports as an argument, and it can then have access to those live export bindings to update them, read them, and set their values, and run the execution in that execute. So you're maintaining some kind of spec semantic. Right. Yeah. So loaders are very much something that happen. You don't want to be loading a loader while node is running, because generally, if you've started running modules, you've started loading, the loader's not going to apply to the modules that are already loaded at the beginning of the app. So that's why it's something that's sort of passed out of band. But that is also something that can be discussed further, how exactly we're going to configure the loader. There might be other ways of doing it. Dynamic instantiate is quite limited. It's something that was just there to provide some of the benefits of dynamic modules. For example, we can import WASM, or we can support loading custom links from the network or whatever. Could implement an AMD loader through it or something like that. But so it opens up some possibilities, but it's quite limited in what you can do. You can't get circular reference handling against the rest of the module tree. You're not getting export star. It's not really attaching modules in a way that's working with their dependencies to properly link all together with the right semantics. It's worth thinking about as we're thinking about the hooks and any new hooks we get. This hook can certainly be reevaluated if we still need it. It's very much just an initial attempt. So some ideas, and these are Strawman and just things to get discussion going, but just throwing out ideas. The unhandled use cases that aren't covered by dynamic instantiation are you can't actually hook into ES modules at all. So if you want to get any information about like what an ES module exports, or change those exports, or like APM bind into those exported functions and add your own wrappers to them, you can't do anything like that. You can't add coverage. So some ideas, one would be something like a load hook, where you could have this asynchronous hook that's called on every module and allows you to customize how it gets the source of a module. And in a load hook, this would be effectively the default load hook, fetch being fs.read file. And the thing that you'd be doing in the middle here, if you wanted to add extra features, is you'd be passing the AST of the source, making some changes, and then you'd probably be reserializing it. To do anything of any real value, you need to do a full AST pass. And that basically means that you've got double passing. So there is very much a performance concern with the load hook. But if you're instrumenting, maybe you don't mind that. So it's worth thinking about. Another option, it's just throwing out ideas, is something like an execution hook. At the moment, we don't have any execution hook in V8. There's no way for V8 to tell you when a module is executed or to hook into that process. But maybe that's something that we could ask for. Maybe that's something we could push for. And the idea with that hook is that it would give you the module namespace before or after execution. You'd have access to live bindings. You'd be able to iterate the export names and see what exports it has and update them. And I think there might actually be a way to implement this with some hacky wrappers. So it might actually be something that could be possible to prototype in Node. I actually have a rough draft of how a wrapper could be constructed for it. So if we're interested in it, it could be something to experiment with. Just following up on the questions here. How does execute differ from create dynamic module? This hook here, well, the difference with this hook is that these are modules that have already been defined elsewhere. We're hooking into the execution of an existing module. So we're not changing the source of the module. We're not changing the definition of the module's dependencies. We are simply hooking into that namespace at the time of execution and getting some information from it. Does that answer your question, Bradley?
To an extent. We've had lengthy talks about confusing things that I don't want to get into right now.
Sure, okay. Is there a way in future we can pass trees into module instantiate? Right, so if we were to want to pass trees back, that would need to be in a format that V8 could work with, because V8 does its own pass as part of the creation of the module. I think it's the module class in V8. So that's a tricky one. The only way to do something like Babel register is dynamic instantiation. Yeah, you'd need to have some kind of source translation process. So it is a double pass generally.
So,
just to clarify, you could with dynamic instantiation do something like Babel register.
Not entirely. Yeah. If they're live bindings, we haven't talked about dynamic instantiate. So live bindings aren't live. You have to manually call set, which can be problematic for some things. And like Guy mentioned, cycles are not doable.
It's a sort of a limited subset of what you would normally get.
Right, you have to execute. Oh, sorry, you have to execute the code. Right. So yeah, the only way is to do disk through the disk currently.
At the moment, yes. Yeah, there's no way to do it right now.
Thanks.
And Gus, that's a good point. how much of the APM inspection stuff is the responsibility of dev tools as opposed to node hooks specifically. And that's very much the sort of discussions that we should be having around this stuff, I think.
So, Guy, a small thing to add to that regarding DevTools and APMs. I think one of the challenges to that is that anything in DevTools would need to be like an explicit API that's communicating over a socket, as opposed to hooks, which are kind of like an open-ended thing that people can write into. So as many APMs kind of distinguish themselves based on what they can do. I would imagine that everything being kind of through DevTools may be a little limited to allow for innovation within that space. But that's just my gut feeling.
Right. That also sort of touches on the code coverage side of things, where the question goes back and forth whether the code coverage in Chrome DevTools is good enough, or whether we definitely need to have the ability for users to do custom things. Yeah. So some more open questions. Which hooks and use cases for hooks should we mark for the unflagged modules release? What other hook use cases should we be considering? How much should be handled through loader hooks versus other primitives, including like the DevTools, or in the default resolver itself? For example, if we wanted to implement the browser map that Justin's talking about in Node, would that be something that would be part of the default Node resolver that you kind of hook into? Or is it something that you'd pass out to a loader hook or something like that? Just some open questions around it. And then what risks should we be aware of in exposing loader hooks? And the registry management I spoke about at the beginning, unloading, reloading modules or arrayed modules. Do we have a role in driving some specs or thought around this? And it's just two more things I want to mention very briefly, and I'll open up to discussion. The one is just my own experience with System.js, and that was, we had these hooks that came from that original Harmony wiki, of these, and the what word loader spec of resolve, translate, instantiate, fetch, and these hooks. And we effectively built out a build system with that. And it's quite natural to think that these hooks should be something that should be used in your build tools, and also ideally shared with the browser at some level. From my experience with that, I would try to avoid that thinking pattern as much as possible, and focus on enabling the hooks to do the right things in Node, rather than trying to think of what hook can be shared directly with the browser or shared directly with your build tool, because those environments have very different concerns. In build tools, you care a lot about caching, and these hooks don't think about caching. And in the browser, you care a lot about, well, for example, with the module map, we're only opening up a subset of resolution. We probably won't open up a lot more hooks. So the level of control is very different. So just to mention that. Yeah, so discussion, if you want to go through some of these questions as well, whatever anyone wants to discuss. And yeah, I'm happy for Miles or Bradley as well to help steer discussion.
I opened up an issue on the queue, which is explicitly to talk about browser and tooling workflow compatibility. So I have a very different opinion, which I'm sure has led to plenty of long discussions between me and Guy. So I somewhat agree that we can have hooks specifically tailored to Node, but I very much want, like I said at the very beginning of this summit, to create a ecosystem that allows you to write something and have it work as many environments as possible. So when we're talking about caching and things, like we just talked about that, since we don't have the ability to replace what source text is at URLs, that's one reason I'm avoiding and actually going against having a fetch hook, or I think it was the load hook here, because I'm really fighting to kind of aim for 4 different environments and just target a subset of them. I'm aiming to get Node as our highest priority to work well for whatever use cases we need. I want us to have some story for ahead of time tooling. So that's like rollup, Webpack, parcel, whatever you're using. And trying to get these loader hooks to be as locked down as possible. There's another place that these can exist, which I've even had proof of concept of. You can run these with source code transforms in an HTTP server, so not integrating against the browser platform. And we can go further and even implement hooks in service workers. And the service worker and the HTTP server workflows are really terrible right now. And I don't think we're going to make progress there. The people I've talked to from WhatWG over 9 to 12 months generally don't see loader hooks as a valid use case in the browser. So I have a lot of concerns from that public signaling, but I still want to strive that we can create this one JavaScript environment, even if we only support a subset in all the ecosystems. Being able to have one that works means that we can kind of foster sharing and not try to isolate or slowly kill another environment.
So, to give an example, like I guess the hooks that we're dealing with, it's not to say that we're not allowing for that kind of like I'm sure like that it's a lovely idea to have, you know, hooks that can work between all environments and you write it once, but to expect us as a committee and as you know, node developers to work out the exact right form of that hook that'll suit every build tool and every browser environment, I think is an unrealistic expectation. So to create the right level of power in Node, which Node is one of the more powerful environments where we have more potential to open things up, then those hooks that do become the general hooks can be implemented within the Node hooks. For example, if Rollup, and I'm a contributor to Rollup as well, decided to implement its plugin system as a node loader, it can do that. If we have the right hooks in Node to allow it to implement its plugin system, but we shouldn't dictate that Rollup should change its plugin hooks and the way it writes its plugin hooks to our API.
But why can't they wrap theirs, create an abstraction layer? I'm not seeking to solve every use case in every environment. I'm seeking just to have a commonality between environments, to share and foster, you know, development across.
Right. Definitely, I think, but just in terms of the difference between the asymmetry between environments, that in Node we have more power, in browser we have very limited power, and in build tools you care a lot about things like parallelization of hooks and caching of hooks. That if we open up in Node what we deem to be the right baseline, and then allow the next level of tools to build on top of that, we should think of ourselves as enablers of an ecosystem. But like we should think in terms of giving ourselves some padding, that we may be giving enough, we just creating enough power to enable that stuff. You know, not necessarily trying to find the exact sweet spot ourselves. If that makes sense.
I can speak at length of this, but Jan has his hand held up. I'll pipe down.
Yeah. So what I would say is that I've heard you say multiple times that, you know, bundlers care a lot about caching and the performance of loader hooks. And for me, that was always one of the big downsides of the current loader hooks or require extensions in Node, is that they don't take performance into account and they don't take predictability into account. So I'm not sure that is a difference between what a bundler would care about and Node would care about. Like, I think that pretty explicitly Node would care about getting the same performance benefits.
Well, I can give an example of what you'd need from caching. Well, for example, for in rollup, we cache the AST. So when you are running the same hook multiple times, you have a cached AST, and that cache parameter would be like a second argument to your load or your translate function, which contains the cached AST, and then you double check that the source M time or the source string matches, and then use the cached version of the AST. Now, the hook in Node just calls load, but then the loader itself can bring in its version of the cache. It doesn't need that cache to be passed to it as a second argument of the load or translate function, because it will have its own source of truth for that, and Node doesn't need to coordinate that source of truth, is kind of the point. Does that sort of answer that, Jan?
I mean, it still doesn't seem prohibitive that caching behavior, or that a caching mechanism across calls to the loader would be part of the design in Node.
So you think that we can look into a cache mechanism?
Well, I mean, I don't see that there's a fundamental problem with, even having an option that you can cache, or having an optional cache option. Like, I don't see that there's a huge fundamental disagreement.
Yeah. So something that that early loader hooks had was the resolve function returned a metadata object, which was just a plain object that the actual hooks themselves could add any information they want, including, for example, caching metadata. And so the resolve hook returned this meta object, which then got passed through to all successive hooks, so that you could use that caching information that you stored without having to relook up, say, the unique module ID in a side table. So I mean, but from a core part of the way the loader works, just at least in terms of every module load being fresh in the node loader, that's I mean, not to say that caching can't be considered, but just in terms of like the use cases are different between environments, and if we try and use the same technical hooks in all different use cases, it's not necessarily a something that should be a goal, I feel. Sorry, Miles?
Hey, so there was a couple different small things. So you had mentioned kind of how can we build something that takes in mind these various build tools, how they're linking things, how they're putting things together. And I think one of the really important things to think about when we're dealing with modules right now is kind of like, what do the tools of tomorrow look like? This is something I've heard members of TC39 discuss in the past, which is the idea that like standards that are being implemented, things that are being done, are partially to solve today's problems, but also to plan for tomorrow's use cases. So, we're not only trying to solve the problems that React has, but we're trying to think about like, what are the use cases that, the next generation of front-end frameworks are going to rely on. And I think that it's an interesting time to consider the same thing, but for build tools, and especially since most build tools are running on the Node platform, I think that puts us in a really interesting place. Where on one hand, we definitely do want to optimize for how tools such as Rollup or JSPM or other tools like are currently implementing things. But I think what I'm hearing a couple of people hint at that excites me a lot is like, how could we think about designing Node's hooks, or how Node exposes these things in such a way that kind of the next generation of tools could build without having to do some of the workarounds that currently exist, due to the limitations of caching or the current problems with require.
Definitely, yeah.
And one thing that I think is a really interesting way of framing it, like Vue has their new CLI that just came out, where they essentially kind of like everything is based on a plugin system. So you have kind of like a base plugin, and then you kind of keep expanding it almost like decorators. And so one way that we could think of at the very least, our loader or like our module specifier resolution, to get to like a really fine-grained example. If we looked at the package map solution as kind of like a baseline implementation, or potentially even a default plugin or a default implementation loader that we have, there's no reason why we can't also have a loader that is, you know, the Node Classic loader or any other infinite number of other loaders, if we kind of from first principles have this idea of it being pluggable and ourselves kind of implement our loaders using that pattern.
Definitely. I mean, if we can, so think in those terms, that's great. And ideally, it should be driven by the build tools, and it should be driven by the people building these kind of cross-platform hooks. You know, I guess I'm just saying not to sort of pre-optimize and preempt what that might be before we know, and you know, grow conservatively out, and not try and jump ahead too far. But I definitely think that's where we are going, and we should be doing everything we can to enable that. Driven by the practical use cases and the practical implementations.
Absolutely. And I think that if we make it easy to extend, one of the most powerful things we can do with it is make a baseline that's completely compatible with the browser, but make it really easy for people to extend and really easy to discover whether or not modules are extending. So we can in turn from that know really quickly, like, hey, are modules compatible with both environments? Can we quickly extend this? What kind of thing you're doing? One thing that I do think will be a huge challenge in all of this, though, is should it be per package or should it be per application as far as how the resolution is exposed, which I think is an interesting challenge and kind of design consideration.
Certainly, scoped loaders are another design like that is something that we have work on, and we can also consider further. Opening up just small parts of the resolution system to hooking. And Bradley will also be discussing the multiple loaders process in more detail, and I'm sure you'll have some more points there to discuss this stuff.
I can't raise my hand, but yes, we can discuss that. That's a very long topic, and we can also discuss at length why I very much don't want to add new loader hooks at the same time.
So I just wanted to respond to Miles's thing before we got too far away from it. So Miles, you mentioned that in like TC39, one common concern absolutely is like looking towards future use cases and future developers and not just trying to solve today's problems. And that's super critical. But I wanted to also point out that one of the things that TC39 had learned over its history is that once things get out on the web, it becomes very difficult to change them, to like evolve further in ways that constrains us. And so, and that's part of why don't break the web is such a critical priority for TC39. But then one thing that I think it would be nice if Node consistently learned early on was the similar danger of allowing too much stuff to happen in the ecosystem in a way that constrains the platform in the future. And so that's an important balance and tension between those two things of designing for the future and also like preventing the premature spread in the ecosystem of patterns. And so like, as we look into what we can do with loaders, I just would really like to see us be careful about what will end up permanently leaked into the ecosystem as a result and how we can minimize that.
Jan has had his hands up there for a while. I'm not sure how long. Jan?
Maybe I should also unmute. Yeah, so the thing that I wanted to call out is for the per package module loaders, or module hooks, I get the appeal, but I'm not excited about the idea because it means that in many cases it encourages people to push repeatable work into the application startup, and I'm a little bit afraid of everyone adding the Babel loader to their packages, and then all Node apps take 10 seconds longer to start up because it needs to load 10 different versions of Babel on startup to compile all the different libraries. So I'm a little bit scared of that prospect.
Sure. Jill? Sorry, we're just running out of time. I don't want to keep everyone from lunch. And Miles, or Bradley, just let me know when we should stop. Jill?
Yeah. My concern is I believe we should, we already have in CJS an extension. It's hacky, but it works and it supports things like Babel Register, APM, et cetera, et cetera. My fear is that if we don't support it when we come out of experimental stage, then migration towards ESM will go slower. So from a balance point of view, do it right or do it fast. I'm personally leaning towards do it fast in this case. That's it.
Sure, and we should probably find out a little bit more about what is required from APM. I know Bradley has presented the current hooks to, I forget which company it was exactly, but one of the bigger ones.
So we have a in the wild thing that New Relic is testing out. So they haven't come back to me and complained, but we do have an example repo of implementing a full APM on our just resolve hook.
And that's working okay for them.
So far. Just speaking to that, the resolve hook is much more insanely powerful than a lot of people think it is. It's very, I don't know, universal in its application. And we can extend things in ways, we could like move loaders onto threads and things, but I'm very hesitant given how much mileage I've been able to get out of that resolve hook to solve APM, code coverage, whatever, to introduce any new hooks. So that's the topic I had.
Also on the, just switching my hand to diagnostics working group for a second, from the APM perspective, we are also trying to work towards getting away from monkey patching as much as possible and introducing an official diagnostics channel so that libraries don't need to be monkey patched and core doesn't need to be monkey patched. And instead, we actually make it work without having to override the module loading system. So on a longer term perspective, hopefully the use case of having to patch modules while loading for APM should go down. At least that is the current hope.
Are there any more questions? Bradley, did you cover your conservative approach topic?
I can speak to that on a comment further, but Jordan's before me. He wanted a spot. I don't know if he did it.
Sure. Jordan?
Yeah, that was my response to Miles about the ecosystem, so I'm good.
Okay.
Okay. So I can finish my conservative approach. So I think both Guy and myself are very conservative, and we argue a lot about loader hooks. And I think it's very good to be conservative, but also to find creative ways to solve the use cases of today. So if people want to figure out things like how to solve caching with our very limited hooks, I'd encourage them to investigate how to do it today without us needing to kind of explode the size and power that we're giving to people, because that means it's easier to leak either implementation details or complexity that we get as tech debt before we've even unflagged modules. So that's it.
And specifically that we should also be thinking, are we going to draw a line where we are now and say that's roughly what we're going to unflag modules on. My biggest concern with that is if we really want to tie ourselves to this dynamic instantiate hook. But I mean, it does sound like people are finding it useful, but I do worry that it will hit its shortcomings soon once people really start experimenting with it. And is that something we really want to be continuing to support as a legacy API once we do replace it? Maybe that's okay. Sure. I mean, we don't need to use up all the time. If that's it, then we can break for lunch.
If we're out, I just want to.
Yeah.
Can I? I'm sorry for kind of taking over the Q&A bit. So some things that are super exciting that we are looking into, various people. I really want to see if we can move loaders onto threads. I know service workers are on a separate thread in browsers, and that can alleviate some of the performance concerns, as well as mean caching can be handled separately entirely from the main context. Also, like, we currently don't have a way to specify modules in memory. We do have vm.module, but that doesn't integrate with these loader hooks. It would be super cool if somebody wants to like investigate further making source text module records a first-class citizen for loaders.
Yeah, speaking of exciting things that are possible with in-memory source text record is also things like supporting HTTP imports by preloading an HTTP archive or any other kind of package format that has URLs in it, so that you can actually have code that imports the same URLs from unpackaged from NPM packages that would also work on the web directly, which is kind of fun.
Jeremiah put a point of order about threads.
I'm not sure if that's like the right category, but also about threading. V8 has now support for doing some like threaded parsing or something, if I remember correctly. So that could also speed things up in that case.
One thing that's worth mentioning along with the sort of URL use cases is that that's not really possible with the dynamic instantiate hook that we have today. So those kind of use cases could be driven by further hook work.
I don't know how you feel about removing it and replacing it with something else, but
I'm more than happy to see it replaced by something else if we can find the right something else.